Alright, so today we will talk about chapter 15, and this is going to be the last chapter of the syllabus. So we probably want to spend a little bit more time here. So we'll cover the first part of this lecture today, and we'll do some homework, and also in the next week we'll cover the remaining part, and then we will do the sample final so that we can get ready for the final. Now we had some introduction of the trig in the last lecture. So some part at the beginning of this lecture is a repetition of those, just to make sure we again grasp the same materials to understand it better. Rules of triangles. We looked at all this before, just as a refresher, that any triangle has three angles, and doesn't matter what kind of triangles it is, all the angles add up to 180 degrees. A right triangle may be thought of as one half of rectangle, right? Because if you divide the rectangle along the diagonal, you will have two different triangles, right? If you look at this one. So these are the classification of triangles by angles. So as you see from here, we can, when we just measure the angle, we start from this line and then we move all the way to the along the anti-clockwise direction, and then come back. Once we come back to the same point, we just complete a round of 360 degrees. So that's why this line is assumed as a reference line. So at this line, at the beginning, we assume this is 0 degree. And then when you start from here and you go here, you have a line like this, and you are covering 180 degree. Anytime you cross the first quarter, that means you basically crossed more than 90 degree, because any quarter must be 90 degrees since the total degree is 360. If you just cover one quarter, it will be 90. If you cover less than a quarter, it will be less than 90 degrees. So as you see from all these 6 circles, we always start counting the degree from this reference line. Okay, so that's the convention. We always use this reference line, and we start counting the degrees. And once we are done, we just, meaning we cover the whole circle and come back to the same point again. That means we covered 360 degrees, because we covered the whole circle. Again, all this from the previous lecture. A triangle is a three-sided figure, and we all know that doesn't matter what kind of triangle it is, we have 180 degrees. Triangle can be classified by their angles, and these are the summary of those classification. The first one is the right triangle, where one angle must be right angle, meaning one angle must be 90 degrees, exactly equal to 90 degrees, right? So another kind of triangle is oblique triangle. There are two kinds. One kind is called obtuse, and another kind is called acute. In case of obtuse, one angle of the triangle must be greater than 90 degrees. In case of acute, one angle must be smaller than 90 degree. So these are examples of all right triangle. You see here they have different orientations, but it doesn't matter, because as long as one angle is 90 degree, you see the 90 degree angle is marked, right? You see the 90 degree angle? They are in different location. They look different, but all of these triangles are right triangles because they have one right angle each. Do you see the right angle? So they have different orientation. So don't always assume, but this is the first one is the most common shape, okay? But the other ones are also right triangle, so be careful. Sometimes, for an example, this one, it doesn't look like it's a right triangle unless you carefully look at this angle. And again, just as a refresher, the opposite of the right angle is called hypotenuse. So here, this is your hypotenuse, okay? In the middle one, the base is your hypotenuse, right? Here, this is your hypotenuse, the right one. So an oblique triangle does not contain any 90-degree angle, and there are two types. Remember, one is obtuse and another is acute. So obtuse triangle, it has angle, at least one angle, which must be greater than 90 degree. You see here, this angle is greater than 90 degree, right? This angle, because think about the 1/4 of a circle. This is larger than 1/4 of a circle, right? Because always reference to the circle, because just from the circle you know that 1/4 of a circle is 90 degrees. So this must be larger than 1/4. This one here is larger than 1/4. This one here is larger than 1/4. So that makes all of these three triangle obtuse triangle, because each of this one has one angle which is greater than 90 degree. Acute triangle, so all of the angle are less than 90 degree. So you see, none of the angles is larger than 90. If you look at all these triangles, none of the angles here is larger than 90 degree. These are the classification of the triangle by their sides. We already know the names, just as a refresher. The first one is equilateral triangle, isosceles triangle, scalene triangles. Number 4, similar triangles have exact angles. They have the same scale size, the sides are proportional, meaning, for an example, you have two equilateral triangles. Now, by the definition, the equilateral triangle means all the sides are equal. And theoretically, when all the sides are equal, all the angles must be equal too. Now, you might have two equilateral triangles. One looks smaller, another looks larger. Now, as you know from the definition and from the properties of the triangle, that doesn't matter how the triangles look like, any triangle always add up to 180 degree together with all these angles. Now, if any triangle looks larger, it doesn't mean that it's more than 180, right? It's still 180. So what is the in the case that when you have two triangles and both triangles are equilateral, and you know that when one equilateral triangle, each angle is what? 60 degree, because each angle are same, right? So they are 60 degree each, which makes 180 in total. So that means it doesn't matter what size and shape, meaning what size they have, if it looks, even if it is look larger, still each of the angle will be same. So if two triangles are similar, now by similar I mean something like this. For an example, you have one triangle and let's say you have another triangle. Now you see here, if you look at carefully, both of the triangles are similar. My drawing is not perfect, but I'm saying they are similar. So, but their angles are exactly equal. Their sides are not equal, but their proportion of the sizes are equal. If you take the proportion of all the three sides of each of the triangle, their proportion will be same, because they are equally larger or smaller compared to the other side. Okay. Now let's go back to the classification. Equilateral triangle, you see here in the left side, all sides are equal. Middle one, two sides must be equal, so two angles must be equal. Here the bottom two angles, this one and this one, are equal because these two sides are equal. Last one, scalene triangle, none of the sides will be equal, so meaning none of the angles are equal. But remember, all of these triangles has 180 degree together with all of the angles. Here is an example of the similar shape. You see here, both of the triangles are similar shape, similar triangles. The first one is larger and the second one is a little bit smaller, but the angles must be same. Similar angles. So this angle must be equal to this angle. This angle must be equal to this angle. And this angle must be equal to this angle. Now let's look at a couple of quiz questions. Which triangle is a right triangle? Right answer is A. C, right? By the definition, a right triangle always has one 90-degree angle. So the right answer is C, right? Right triangle must have one angle which must be equal to exactly 90 degree. In a right triangle, angle A equal to 60 degree. What is the angle B? Now here, if you look at carefully, angle C is 90 degree, right? Because it's a right triangle, right? So you know that angle C must be 90 degree. So and it's given that angle A is 60 degree. Now how about angle B? Remember the total. What is the total? So you can find it from there just right away. It must be 30 degree then. Because this is 90, this is 60, so together it makes 150, right? So this is 90 and this is 60. It's 150, so its left is only 30. So B must be 30 degrees, so the right answer is D. What is B here? How much is B? It must be 50 degree, right? Because the total must be 180. So the right answer is A. What is B here? It's 20 degrees, so the right answer is A. Very similar question. What is angle B? It must be 45, right? Because 90 plus 45 is 135 and you are left with another 45. So angle B is 45 degree. Now in this question, this is not a right triangle. So you are given two angles. What is the other angle? So what is the angle C? Must be 80 degree, right? Because the two angles add up to 100 degree. And you are left with 80 degrees. So the angle C must be 80 degrees. So the right answer is B. What is angle C here? It must be 60 degree, right? So the right answer is D. What is C here? 60 degree, right? Look at carefully. All the angles are 60 degree here, right? A, B, and C. So any guess that what kind of triangle is this? See, when all the angles are equal, it means that all the sides are also equal. So by the definition, it must be equilateral, right? Now we'll talk about a theorem which is one of the most useful and important theorem in trigonometry. Okay, this theorem is named by a scientist, Pythagoras, who has proposed this theorem. Okay, now by this theorem you will be able to find out the length of a side using a formula of a right triangle. Before we start, remember, anything we discuss or anytime we can apply the Pythagorean theorem, the triangle must be right triangle. So this theorem is only applied to right triangle. None other triangle can be applied here. So this is only true for the right triangle. Now, so just from this triangle, you know that the angle C is 90 degree. So what is the hypotenuse? The side AB, right? So what we do is, if you look at carefully, we write the angles using the capital letter, uppercase letter, and we write their side by lowercase letter. You see the lowercase c here? The reason we name it lower c because it's just opposite to the upper C. Similarly, this is small a because it's just opposite to the capital A angle. Similarly, this is small b because it's opposite to the angle B. So all the angles are written in capital B. You know, this is a convention of writing right triangle. So before we apply the formula, we just want to make sure that we understand how the triangles will be shown every time. So you will see all the angles in ABC, and you will see all the sides in a, small b, and a small c. And also be careful, the side will be the opposite side. So small c must be to the opposite of capital C. Small a must be to the opposite of angle A. You see the opposite here? You see this is an angle, right? So opposite means this side. So this is an angle, so the opposite must be this side. Now, and also, you know that the opposite of the right angle is called hypotenuse, right? So small c is your hypotenuse here, right? Small c. Do you see the small c here? Okay. And also, one of the angle is always designated by a Greek letter called theta. Theta is a Greek letter which is always used. You see the theta here? This is the theta. Theta is used to denote the angles. So one of the angle must be denoted as theta. Okay. Now this angle here, let's say we remember that one angle cannot be the right angle, other two, because we know that C is right angle. So in this case, your theta can be either A or B. Now let's say in this picture, you see that A is your theta. Okay. Now these are all the formulas we have to calculate the sides of a triangle using the Pythagorean theorem. Now, if you look at this formula carefully, we have written the same formula in 3 different ways. Now, what does this formula do? Look at this carefully. This formula will be able to give you the length of a side when the other 2 lengths are known. You know, there are 3 sides in a triangle, right? Now let's say 2 sides are known to you, and you are trying to find the other side. Now this formula will be applied at that time. You can just apply this formula and find the other side. Now here, look at this. The first formula here is for the C. Second formula is for the A, and the last formula is for the B. if you look at more carefully, the first formula for the C, you are adding a square plus b square, a square and b square, and you are taking the square root of them. For the next two, you are not adding, you will be subtracting. So when you are calculating the A, you are subtracting the b square from c square, and when you are calculating b, you are still subtracting from c square, but you are subtracting a square because you are trying to find b, and every time you are taking the square root. So we'll see, definitely we'll see some application. I'm saying we'll see some quiz for sure, but before we start the quiz, we must want to understand again one more time that this formula will give you the side of a triangle, right triangle, when other two sides are known. You must know two sides, then you will be able to find the other unknown side.
But you can use either one of those formulas.
Yeah, because all of these formulas are same, but now the reason we gave you the same formula in different format is this. Let's say you are trying to find B when C and A are given, so you should pick the last one, because remember the one that you are trying to find, that should be isolated, right? So you see here the B is isolated. Now let's say you are given C and B and you have to find the A. Which one you want to use? You want to find the A. You must use the middle one, right? Because you see the A is at your left. So that's why we rearrange the same formula in different format, so that you just don't have to change their side and then isolate the unknown. It's already given. So you can just use which one you want based on what is given and what is unknown. If you are trying to find the hypotenuse, which is C, you must use the first one. You see the C is at your left. Now let's look at a couple of examples. This example is a real life example that will give you a better idea that why this Pythagorean theorem is so important. Now a boat crossing a river is subjected to two forces. Number one, the boat's motor, for sure. Number two, the river's current. Okay. Now the latter will cause the boat to land downstream. If the river is 300 meters wide and the total distance that the boat travels is 500 meters, how far does the boat land downstream? Now here, look at carefully, this is the picture. Here, let's say you started from here, okay? You cannot just cross the river along this line because there are two different forces. Due to, if you think this way, you are being forced by the motor this way, but you have another force which is the current of the river. So instead of moving, just crossing the river vertically, you are basically following this direction to cross the river. You cannot basically pass from here to here. Instead of that, you are passing along this line because two forces are basically pushing you at the same time. Now, you just saw that you basically crossed 500 meters in total, which is along this line. But what do you think? Do you think the width of the river is 500 meters? So width is probably this one, right? Which looks much less than 500. But at the same time, you had 300 meter. Wait. Okay, so I think we are looking the picture in a different way. So let's say this is the river, and you started from here. Okay, now this is the width of the river, and you started from here. So you basically wanted to cross this way, but you could not do that because you were being forced by the current here. Your motor was pushing you here. So at the end, you basically followed this path to cross the river. Now this is the width of the river, which is 300 meters. But at the same time, you know that you basically crossed this way, which you did not want to, but because of two forces. Now, can you find that what is the downstream distance, meaning what is this side. Now think it as a triangle. You see this is a right triangle, right? Now if you look at this as a right triangle, so the D here can be calculated using the Pythagorean theorem. Now look at carefully, which is your hypotenuse here? 500 meter line, right? That is your hypotenuse, right? Now, and you are trying to find D. So can you tell me which formula you want to use? A, B, C. There are three different ways of formulas are given. Now, first of all, you are not trying to find the hypotenuse, right? Hypotenuse is given. If you remember other formulas, if you go back here, remember the other formulas, there must be minus sign at the middle. If it is not hypotenuse, right? Either A or B. So if you look at C, that's addition, but except C, A for A and B, you are trying to find either or B, A or B. It's up to you how you want to calculate. But remember, when you are trying to find A, B square is subtracted, right? And when you are trying B, A square is subtracted. But every time you are subtracting from C square, whereas C is your hypotenuse. Now if you come to our problem again, so here the hypotenuse is 500 and that must be at the beginning, right? Now you see the right answer must be B, because the B is the only choice you have where hypotenuse 500 meter is at the beginning and 300 meter is subtracted, right? Because you know all the formula, if you go back again, look at this. In both of the formula, the C square is at the beginning, right? You see the C square at the beginning for A and B. So here, that C square means the 500 meter square here, because C is 500 meter in this example. So the formula we are going to apply is B. And how much you get if you apply the formula? Anyone can try your calculator and see whether you can find the answer. When you apply the formula, 500 square minus 300 square, and you have a square root. See whether you can find it using your calculator. So Mr. Blanton has 400 meter, so the right answer is C. What do you think? Anyone has a better answer? $400, so the right answer must be C, right? Alright, so we found the right answer is C. Now we'll try some more questions like this, and all these questions will be based on Pythagorean theorem. Now in an AC electric circuit, the impedance Z, look at the picture, impedance Z, resistance R and reactance X are related by a right triangle. See, all you need is, you have to understand how the problem is modeled by the triangle. Once you see the right triangle, that's it. You can apply the Pythagorean. Now you see how the formula is applied. So Z is basically your hypotenuse here, right? Z is the hypotenuse. Now if R is 60 ohms and X is 105 ohms, what is the magnitude of impedance? So you are basically trying to find the Z. Can you tell me what is the formula you are going to use? Remember, at the end, you are just dealing with a triangle, right triangle, and you are trying to apply the Pythagorean theorem. That's the basic of any right triangle of the world. Now here you are trying to find the Z, right? So the right answer must be A, right? Because when you are adding, it doesn't matter which order you follow, because you are adding. But when you subtract, in case of A or B, small a and small b, you always subtract a square, either a square from c square or b square from c square. Now the right answer is A here. Any question about this one? What is z? How much is z? Can you calculate the z for us? How much is z?
121.
Everyone has 121 ohm. So the right answer is C. Another example. Apparent power, active power and reactive power is given, and all these are related by Pythagorean theorem, like S square equals to P square plus Q square if S equals to 50 volt amps and Q equals to 30 VAR. What is the active power P in the circuit? All you need is, you need a right triangle, and you have to understand what is given and what is unknown. Here, look at this carefully. If you look at the triangle here, P is unknown, right? So how to calculate the P from here? What is the formula you should pick? A, because the P is not hypotenuse, right? See, the hypotenuse is S. So A is ruled out because A looks like this is a formula for hypotenuse, right? Now, out of B and C, we can rule out C because, we always have to subtract from the C square, right? Are you subtracting from C square? This should be C, right? Remember, the hypotenuse is the largest side of the triangle, right triangle. Hypotenuse is always the largest side. So just by looking at this, anybody will know that 50 must be the hypotenuse, not 30, because that's larger than 30 for sure. So the right answer must be B. And even from the picture here, I'm saying the picture of the triangle, if you look at the picture of the triangle, you see the hypotenuse is 50 volt amp, right? Any question? Let's try another example. Oh, okay, let's solve it first. I think we did not solve it yet. Now, what is P? This is 40 watt. All right. Now, from this slide, we will talk about trigonometric functions. Okay? I think we'll stop here for today, and then we'll continue from here in the next class, because this is the last chapter we have, and we basically allotted 2 weeks for this chapter, because we know that sometimes we have issue with the trigonometry part. So that's why we wanted to spend 2 weeks here. So this part we'll discuss next week. Now we'll go to the pause, and we have 3 homeworks for chapter 3. We'll not be able to do all the 3 for sure, but let's start with the homework 1, and then we'll continue in the next week. And in the next week, we'll be done with this chapter. We'll be done with all the pause homework for this chapter, and then I will remind you to finish all the previous homeworks if you have not done it yet, or you also want to, if you want to finish, let's say do and try those things again to get 100%. Those are open. You can do it again. Just remember that we want to make the last week free so that we can practice the sample final, because the final will be the comprehensive one, which will cover everything you have in the syllabus. Now you know that from the beginning we have covered a lot of chapters which we might forget, so we want to refresh all of those so that we can get ready for the final. And just if you forget your date of the final, check the schedule that I gave you. Just probably May 3, right? Check the course outline that I gave you at the beginning of the semester. I wrote the date of the final. It's probably May 3. And also check the time. The time is not same as the class time. Okay? Check the time and check the date. Make sure you know when is your final, so that if you have some other appointment, you can make some arrangement to have your final. Now let's go to pause and start with the homework 1 of chapter 15.